All right, talking about circles. Let's look at writing the equation of a circle. We already know what a circle is. A circle is a set of points that are equidistant from the center. So here's the center 2, 3, radius of 4. All of these points are 4 units from the center. So if I drew out to even here, anywhere, any point on the circle, any point x, y on the circle is going to be 4 units from this center point 2, 3. Now, I want to really talk about how this works using the distance formula. Distance formula. I can turn any thing on the coordinate grid into a right triangle. Distance formula is just finding this horizontal distance squared plus the vertical distance squared equals the hypotenuse squared. Well, how do we find this horizontal distance? Well, however far we went, x, which we don't know, minus the 2, the difference between our x's. Difference between our x's squared. Now for the vertical distance, the difference between my y's, so y minus 3 squared, equals that hypotenuse squared. Now what about any center HK? And there's a radius of R. So let's just draw any old center HK, circle, R for the radius. Any point on the edge is XY. And the reason we use XY is because that's constantly changing. The center is going to remain constant. But there are millions and millions of points going around the circle. So that's why we can't be specific here. We've got to leave this as XY. Now again, I can make a right triangle. This is going to be the difference of my x's, or x minus h. Difference of my y's, y minus k. So again, it'd be x minus h squared, and then y minus k squared equals r squared. This is the generic form of a circle. It's actually what we consider the graphing form of a circle. The reason we call it the graphing form is because we immediately know where our center is, and we immediately know what our radius is. Let's try another one that's maybe not so specific. We have the center is at the origin. So that makes it pretty easy for that HK, right? HK is the center, and if it's at the origin, that means it's 0, 0. So I have x minus 0, oh, that's just x squared. Then y minus 0, that's just y squared, equals, now I need to figure out the r, right? So let's go back over here. We have a point on the circle, 2, negative 5. 1, 2, 3, 4, 5. There we go. There's the point 2, negative 5. Now I know that's on the circle. Here's that radius. So the circle's pretty big here. La, 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 la. Alright, I don't know how long that radius is, but I can use good old Pythagoras to figure it out. This was 5 steps down, 2 steps over. So again, r squared would equal 2 squared plus 5 squared. R squared equals 4 plus 25, which is 29. Now, what's nice here is that we really need r squared to complete the equation. We already have r squared. Save yourself some work, man. If you already know r squared, just put that in there. Alright, last example on using the information to find the equation. I have endpoints at -1, -3, and then 5, -3. Those are the endpoints of my diameter. I really want you to think about that vocabulary, diameter. 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 What do I know about the diameter? Well, first of all, I know it goes through the center. So the center has to be on that. Also know that the radius is half of the diameter. So let's find that halfway point, which one way to find your halfway point is to find the midpoint, which is the average of these 2 points. If I average these 2 points, -1 plus 5 gives me 4. Half of that is 2. And then halfway between -3 and -3, well, luckily that's easy. That's just -3. So that is my center. Now, the entire diameter was, let's see, that's 5 units and one more. The diameter was 6 units long, so that means my radius is going to be 3 units long. So let's see how easy this works. The equation, the general one, is x minus h squared, y minus k squared equals r squared. X minus, and this is the x value from the center, so that's going to be x minus 2 squared. Y minus a -3, that's going to be y plus 3 squared, equals r squared. Well, r is 3. When I square that, I get 9. Now let's look at going in the opposite way. What if I'm given the equation and I'm asked to graph? So our first two are in graphing form, which means it's really easy. I can easily find my center. X minus would be a 1. Y minus, well, nothing, so that's a 0. So my center is at 1, 0. My radius is the square root of the other side, so the radius is 3. So I would go center is 1, 0, and we're going to go out 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and draw a circle. Next one, x minus my h value, but that's a plus 2. So that means that my center actually had to have been at -2 and a positive 3. Radius, square root of the other side, so that had to be a 5. -2, up 3, here's my center. Count out 5. 1, 2, 3, 4, 5. And it's usually easiest just to go 3, 4, 5, up, down, right, left, 2, 3, 4, 5. Can't really go up there because I'm running out of room. But we have that idea. Now, we're starting to get in this next one a little bit closer to what is called standard form. Now, standard form is when everything is multiplied out, and I don't have parentheses, and everything actually usually is on one side. What can I do to make this look a little bit more like the graphing form? Well, easily, I'm just going to divide, but since I can divide everything by 4, I am. That gives me x squared plus y squared equals 32. Now, I wanted to bring this one up mainly because it didn't have a perfect square on the other side. Center on this one is easy. The center is 0, 0. But the radius is that square root of 32. Now, I want you to remember back. Square root of 32. That's going to have a 2 and a 16. That's 4 square roots of 2. I also want to think about that estimate. Where is this going to be? Well, the square root of 36 is 6. The square root of 25 is 5. So this is going to be approximately, I would say, 5.5. When you're graphing, you'll need to take that into consideration. So we're going to go about halfway there. So it's not an exact radius. It's not an exact square root. Now this last one is in what is considered standard form. Getting from it back to our graphing form is sometimes very difficult for students. So I wanted to walk through this very carefully. First off, we can't do what we did on the last one, which is divide everything by 4. Not everything is divisible by 4. You'll notice that 135 is not divisible by 4. Now, you could divide everything by 4, and then you'd end up with some fractions that get really ugly. I'm going to help you avoid that. The first thing I'm going to advise you to do is to group the variables. You'll notice that the x's aren't together and the y's are not all together. So if I group them, I'll have 4x squared here, and I'm going to put the 40x next to it. I'll even put the 4y squared here, minus 24y next. Now the other thing I'd like to do is, since this doesn't have a variable, I'm going to move it. It goes to the other side and it becomes negative 135. Now, I'm kind of noticing that there's something missing here. To get it in this form where I have something squared, I'm going to have to do what is called completing the square. But we have a little problem here. There is a number in front of our x squared and our y squared. That is not going to be helpful. So let's take a moment and factor out the leading coefficient. In other words, I don't want this 4 in front of each of these things. Now I'm going to take it out, and I'm going to leave myself a lot of space there. Alright, so just bear with me for a moment. When I factor 4 from the 4x squared, I'm going to have x squared. Factor 4 from 40x, I'm going to have 10x. I'm leaving a space here, because when you complete the square, you're going to fill in something that's missing there. For the y's, factor out the 4, I get y squared. That'd be minus 6y. And there's something missing here. I'll need to figure out what that is when I complete the square. Now, thinking about how that works when you're completing the square. We want this in parentheses to become something squared. Same thing here. Something squared. Oops, I went ahead and wrote the y. Why did I write a y? Well, because that had a y. So this must have an x. Now, if you remember how this works, half of this goes here. So half of the 10 goes here. That's going to be plus 5. Now, what I'm missing is this number squared. So what's that squared? That's plus 25. Now, we have to be very careful here. When I add this here, I need to add it over here. But this one's going to work a little differently than what we've done in the past. Do you notice how there's a 4 outside this parentheses? That means I'm not just multiplying or adding 25. I'm really adding 4 times 25. Now let's look at how to complete the square for y. Y, it's y squared minus 6y. So half of this is going to be negative 3. Negative 3 squared is going to be 9. So I'm going to add 9 here. But I have to be careful. It's not just 9. It's actually a 4 times 9. Now, I'm going to take just a brief moment to clean up the right side. This was negative 135. 4 times 25 is actually 100. 4 times 9 is 36. That's going to be negative 135 plus 136. That's going to give me a 1. Now, we're almost to that graphing form. The last thing I need to do, in graphing form, we don't have anything in front of our parentheses. So I'm going to divide by 4. That's going to give me x plus 5 squared plus y minus 3 squared equals 1/4. Now, I'm going to go ahead and save some time and not actually graph this, because I think you can graph any of them. But let's go ahead and write down what the center and the radius are. The center Since that's a plus 5, that means my center is going to be negative 5. Y minus 3, that means this is going to be a 3. And the radius is the square root of that right side. So it's going to be 1/2. Let's try another one where we have to complete the square. Now this one's going to be a little bit less complicated. But I want you to see one more example. X squared plus y squared minus 2x plus 4y plus 1 equals 0. I want to group the variables together. So x squared minus 2x, leave a little space, y squared plus 4y. I'm going to move the 1. Now, this one didn't have coefficients in front because I felt like being nice. I need to take this and turn it into something squared plus something squared. I am missing something here and here. Let's think through this. This is going to be an x. It's going to be a y. Half of this is going to be negative 1. Negative 1 squared is plus 1. You need to add it to both sides. For the y's, half of 4 is 2. 2 squared is 4. Add it to both sides. Now all I have to do is simplify. Negative 1 plus 1 is 0, plus 4 is 4. My center is going to be 1, negative 2, and the radius is going to be the square root of 4, which is 2.